Hello students, let us study about the chemical properties of alkanes in this video. As already mentioned, alkanes are generally inert towards acid bases, oxidizing and reducing agent. But however, they can undergo some following reactions under the certain conditions. So let us see what are the chemical reactions which it undergoes. That is first substitution reactions that we need to discuss, combustions, control oxidation, isomerization, aromatization, reaction with steam and pyrolysis. So these are the reactions which we need to discuss in this video. So let us discuss these reactions in detail. So first let us discuss the first, that is the substitution reactions. Now I will tell the name what is the substitution means. Substitution means if something is get removed and in the place of that some other group get attached, that is called as substitution. So let us take the example here, that is methane. Methane with chlorine, what it gives rise to chloromethane. So here what is actually happening here, better I will expand this, that is methane. So instead of condensed way, I will write in the fully expanded structure formula for this methane. Now what happened, if from this one of the hydrogen get replaced by one chloro group. So what I can do here, I can remove one hydrogen from here. So that means the process in which one or more than one hydrogen atom of alkanes can be replaced by halogen. Like here I have replaced one hydrogen of the alkane and I am replacing it with a halogen Cl. So what we got the product, that is C and 3 hydrogen. So we can write it as CH3 and Cl. So that is what the product which is formed as chloromethane. So what I done here, I replaced one of the hydrogen and I substituted chloro, or the we can say halo group in the place of hydrogen. That is what is called as a substitution. Why it is substitution? Because one is get substituted in the place of other. That is why it is called as substitution reaction. So I can remove one more hydrogen from here. So this one or more hydrogen of alkane can be replaced by halogen. So one hydrogen I already replaced, and now I will be doing with the other one. So I am replacing one more hydrogen from here. So now what I get the product by keeping one Cl in the place of this one. So what I got the product now, that is CH2Cl2. What I can write the product now, it is CH2 because 2 hydrogen and 2 Cl, that is CH2Cl2. Now what I can do, I can replace one more hydrogen from here. So I will rub it out and I will keep one Cl from in the place of hydrogen. So now what we get the product, we got CHCl3. So now what is the product we got here? That is, I can rub this part and what I can write here, that is CHCl3. That is a trichloromethane. So we got a substitution of 3 halo group is taken place here. Now one more hydrogen is there. So that also we can replace with the halo group. So I will rub it this one hydrogen and I can keep one Cl in the place of this one. Now what we got the product here, that is the product we got here, that is actually 1 carbon 4 chloro group compound. That is what we called it as a compound, that is CCl4, that is carbon tetrachloride, or we can call it as tetrachloromethane. What is the common name? That is carbon tetrachloride. but it is named as IUPAC, it is named as tetrachloromethane, because one carbon, that's why the word root is meth. So this is actually what is called as a substitution, and here the substitution of a halo group is taking place, that's why it is called as halogenation. So what is substitution reaction? One or more hydrogen atoms of alkanes can be replaced by halogens or nitro group or sulfonic acid group. And here we are discussing about the replacement of hydrogen by halogen, that's why it is called as halogenation. The word halogenation, I told you halogen is representing for the halogen group. So halogenation means what is actually taking place here? Substitution of a halogen group is taking place, therefore it is called as halogenation. That is by replacing the hydrogen with a halo group. So here chlorination is taking place, because which halogen is substituting here? That is chlorine. So we can call it as chlorination. This in general it is written halogenation. Particularly we can name it as chlorination. Chlorination is taking place here. And you can see the first step was explained here. That is one Cl is taking the position of one of the hydrogen. So here the side product is removed as HCl, because one Cl is here and what H is removed from here, that is HCl is a side product form. So here the hydrogenation, as I told you, we can write it in this way. So first hydrogen, when it is removed, then it formed chloromethane. In the second step, second hydrogen is removed. So what is formed? Dichloromethane. That is already I explained by expanded way. So first I have removed one hydrogen and I substituted halo group in the place of hydrogen. So what we got here? We got here chloromethane. One second halo group gets substituted in this one. So what we got? Dichloromethane. When third chloro gets substituted, trichloromethane, and at last fourth one gets substituted to form tetrachloromethane. That is in general we call it as a carbon tetrachloride. CCl4 is carbon tetrachloride. That is a common name, but the IUPAC name for this one is tetrachloromethane. Here trichloromethane, dichloromethane, and this one is chloromethane. It's very important reaction, all these reaction. So again I will tell you, no need to by heart the equation, just learn the method what I had done here. That is, remove one hydrogen from here and one Cl from here. That is what it is removed here. HCl is removed. Now what is remaining here? One hydrogen is removed. So how many hydrogen is remaining there? 3 hydrogen is remaining, that is CH3, and one Cl is remaining here, that is CH3Cl. So in the same way you can do the other also. So this reaction is taking place in the presence of light, that is written here H nu. And it is found that the rate of the reaction of alkanes with the halogen, when we compare the reactivity, which is more reactive towards the halogenation, fluorine is the most reactive than chlorine, than bromine, than iodine. So that is it is found that the rate of the reaction of alkanes with halogen is in this order. And when we compare the degrees of alkanes, 3 degrees most reactive, then 2 degree, then 1 degree. So this is what actually is the sequence which you need to remember for comparing the reactivity. That means 3 degrees more reactive, then 2 degree, then 1 degree. But when we compare the reactivity of these, we can go in this order. Since this equation is taking place in the presence of H nu, that is the light, that's why it is written the presence H nu. Whatever presence are there, that will used to write on the arrows. Since the halogenation takes place either at high temperature or in the presence of diffused sunlight or ultraviolet, that's why it is written H nu here. This reaction is taking place either at high temperature. High temperature means nearly 573 to 773 Kelvin. Nearly at between these temperature, that is 573 Kelvin to 773 Kelvin, or in the presence of diffused sunlight or ultraviolet light. That's why it is written H nu above the arrow. So this arrow on the above we written H nu, that shows the presence, that is this reaction is taking place in the presence of diffuse sunlight or ultraviolet light. Next we'll be going to discuss the mechanism of this halogenation reaction. That is the mechanism, as I told you, it gives the complete description about the each steps involved and also the kinetics of that reaction. So we'll be discussing the mechanism in different steps. First step is the initiation step. Initiation means the beginning step. So what is actually happening? The reaction is initiated by the homolysis of chlorine molecule in the presence of light or heat. So again we are coming with the concept what we have learned already. We have learned the concept of homolysis. Two type of cleavage we have learned in the previous chapter, that is homolysis and heterolytic cleavage. Homolytic means that is the chlorine molecule. The cleavage is homolytic means here the electron, the shared pair of electron is equally shifted to both the atoms. So here we will be getting the product, that is free radicals. So homolytic fission will result in the formation of free radical here. So in the case of chlorine molecule, first in the presence of the diffuse sunlight or in the presence of ultraviolet light, which is actually makes the cleavage of that bond. The bond get cleaved in the presence of H nu, and the cleavage is homolysis cleavage. That's why it results in the formation of chlorine free radicals. It is very important to note free radicals. This dot should be made clearly. This shows the free radical. How we represent the free radical? By keeping the dots. So this is what actually initiation step which is taking place. Next, after the initiation, what happened? The propagation step is involved. So what is propagation? Now the chlorine free radical attack the methane molecule and takes the reaction in the forward direction by breaking the CH bond to generate methyl free radical with the formation of HCl. So what is actually taking place? In the initiation step, we got this free radical, that is chlorine free radical is formed. Now that chlorine free radical, what it will do? It will attack the methane. The chlorine free radical, this is what the chlorine free radical which is formed in the first step, it attack the methane molecule, and the reaction will be taking place in such a way that there is a cleavage of CH bond, because here methane means here 4 hydrogen are there. That means it involves a cleavage of CH bond. One of the CH bond get cleaved, and that H and the Cl together what forms the HCl is formed. Here also which type of cleavage is taking place? Homolytic cleavage is taking place. Homolytic cleavage means the one electron will shift to this carbon and one electron shift to this carbon. So now we have a methyl free radical and H dot and Cl dot, that is the hydrogen free radical and Cl free radical together gives HCl. So what is formed here? The breaking of CH bond takes place and generate the methyl free radical, and there is a formation of side product HCl. Now in the next step, this methyl free radical, now it further react with the further molecule of chlorine. So what it formed? Again the homolytic cleavage taking place. So what we got here? Cl dot, Cl dot. Now CH3 dot and Cl dot together makes what? CH3Cl. And now the Cl dot is again here. So what happens it will propagate. That means it will takes the reaction in the forward direction by breaking up the CH bond and generate the free radicals. At each step, free radicals are formed which will further continue the process. So what is happening next? Again what happened? This Cl dot next combined with this CH3 Cl. Again there is a cleavage of CH bond, cleavage of CH bond. So it results in the formation of free radical plus HCl. Next what happened? This combines with again next molecule. So it form a, so what happened in each stage, what happening? The substitution is taking place and that is actually by taking place in the formation of free radicals which is formed in each stages which continues the reaction. So that is what called as propagation. The reaction is the reaction goes in the forward direction by the continuous break of CH bond and it generate the free radical. Methyl free radicals are formed and the side product is formed. So this is what actually mechanism, and mechanism is very important to learn. But the reaction is not stopped now. The reaction has to terminate. That means there should be termination. There should be some process by which we have to stop this continuation. So termination step, that is the reaction stops after some time due to the consumption of the reactant or due to the following side reaction. So how this reaction is get terminated? We have to because the reaction is continuing because of the free radical. So if the free radicals are getting combined to form chlorine, so what happens there? The reaction get terminated, or either by the methyl free radical get combined to form methane, or by this, but that means the when the free radicals get combined, so that the reaction get the chain termination takes place by these ways. So these are the possible ways in which the chain termination takes place. So next is the combustion. Combustion means we are familiar with this word combustion. That is a burning process. We can call it as combustion. So combustion or the burning is nothing but the reaction with oxygen. So something is burning, that means it is reacting with the oxygen. So we can write the combustion of alkanes, that is alkanes on heating in the presence of air or dioxygen, because air having dioxygen. So when it is completely oxidized into carbon dioxide and water with the evolution of a large amount of heat. As we know that when something will burn, it will gives a large amount of heat, like when you burn the wood or any petrol, diesel, kerosene, what happens when it burns, it will give rise to lot amount of heat and energy. So we have learnt in the alkanes in the general introduction part, that is the fuels like petrol, diesel, LPG, CNG, all these having actually mixtures of hydrocarbons, that is usually alkanes. So that is alkanes are the very good fuels because they can react with oxygen, that is burned with oxygen to give rise to large amount of heat. So here actually the reaction is the reaction with oxygen. So methane with the reaction with oxygen give rise to carbon dioxide and water. So when there is a complete oxidation, this is called as oxidation reaction because there is a reaction with oxygen. So combustion process is an oxidation reaction, and when there is a complete oxidation as it is taking place here, so there is a formation of the product, that is carbon dioxide and water. So if you take the next case, here also this is also one of the alkane, that is butane. 4 carbon alkane, that is butane, when it is burnt in air or in the presence of dioxygen, again we are getting the product carbon dioxide and water. So we are getting the product carbon dioxide and water, but you can check here the balancing will be different. So in general we can learn this equation, that is combustion reaction, we can learn in this equation in this way. So it will be very easy to do the balancing when you learn this equation, that is CnH2n plus 2. That is the general equation for alkane. The general equation for the alkane which is given here, that is CnH2n plus 2. And oxygen, how much you have to take? 3n plus 1 divided by 2 you have to take. That is why I told you when you learn this equation, balancing will be easier. Okay, so what is N here? N is the number of carbon. So how much oxygen you have to take? What is the stoichiometric coefficient? That is 3n plus 1 divided by 2. Like if n is 1, so 3 into 1 plus 1 divided by 2. You have to take in that way. And what you get the product? N number of carbon dioxide will be getting, because n number of carbon is there, so n number of carbon dioxide, and n plus 1 number of water is the formed here. So instead of learning the particle equation, better you learn this general equation. When you learn this general equation, if any alkane is given to us, we can write the product very easily. Product is in all the cases the product is carbon dioxide and water, but the balancing you have to do, and for that better to learn this equation. So due to the evolution of a large amount of heat during the combustion, that's why the alkanes are used as a fuels. I told you, like LPG, CNG, and the other fuels we have like familiar with the petrol, diesel, kerosene, all these having mixture of alkanes. That is actually, it is due to the combustion, it is giving rise to a large amount of energy, or the heat is given out. That's why it is a very good fuel. Next, when there is the incomplete combustion, so there we are getting the product. Instead of carbon dioxide, what we are getting here, carbon is getting the product. Just now we have learned the combustion, that is complete combustion, in which there is a formation of carbon dioxide and water as a product. But during the incomplete combustion, we are getting carbon and water as a product. And where we use this carbon, that is carbon black is formed, which is used in the manufacture of ink, printer ink, black pigments, and as a filters. This is the carbon black which is formed here. And you are familiar with this carbon black also during the combustion of the wood, or somewhere you can find the black carbon. So that is actually is used for making the inks and the printer ink, and the black pigments are used for by using this carbon. That is called as carbon black. It's very important reaction. The incomplete combustion give rise to the product carbon plus water, but complete combustion give rise to the product, that is carbon dioxide and water. And where we use this carbon? For making the inks, printer, etc. The next property is, that is controlled oxidation. That means when alkanes are on heating with the regular supply of dioxygen or the air at high pressure and in the presence of suitable catalyst, it gives rise to a variety of oxidation product. Just now we have learned the two. Already we have learned the oxidation, in which there is complete oxidation. So that's why we are getting the product carbon dioxide and water. But if the oxidation is taking place in the presence of suitable catalyst, in that case we will be getting variety of product. Like the same reactant which is undergoing oxidation, that you can check in the first and second equation, the same reactant, but the conditions are different here. That means the presence is different and the product is also different. So that is what are called as controlled oxidation, because what is the product is forming, that is actually decided by the catalyst. So catalyst is actually directing the reaction. What is the product to be formed here? So that is why it is called as control oxidation. So in all these equation you can check that in the presence of copper, the product is formed as a methanol, that is an alcohol. Here there is a formation of aldehyde. Here there is a formation of acid. So here also there is a formation of alcohol. So when the presence get variate, what happened? The product also get variate. So that is what called as controlled oxidation. And this is also oxidation because there is addition of oxygen. Next is isomerization. We are familiar with the word isomer. So what is isomerization? That means one isomer can be converted into another isomer. That is N-hexane. N-hexane is a straight chain compound, 6 carbon alkane straight chain. That is in the presence of N-hydrous AlCl3. In this presence what happened? There is a formation of the isomers. Isomers are formed because when you check here, whatever the product we are getting here, these are the isomer of this one. So 2-methyl pentane and 3-methyl pentane, these are the two isomers which are formed. So this process is called as isomerization. N-alkane, on heating in the presence of N-hydrous aluminum chloride, that is AlCl3, and hydrogen chloride gas, isomerized to branched chain alkanes. You can see the branched chain alkanes are formed and the major products are given below here. So some of the minor products are also possible which you may think over it. But minor products are generally not reported in the organic reaction. So what are the main product which is formed here? That is a branched compound of the reactant. The reactant is N-alkane. Why it is called as N-alkane? Like here N-hexane. What it means that all the carbon are in the straight chain. So better I can expand this equation. This structure CH3, CH2, CH2 4 times. That means CH2, 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 CH2 and 1, 2, 3, 4, 5 carbon and the last carbon is CH3. So this is what actually I expanded this one. But this instead of writing CH2 4 times, you can write CH2 in brackets, you can write 4. So here what happening, the N-alkane is converted into branched isomer. You can see the branching is there. It is a branched isomer. And why it is called as isomerization? Because it is a reaction in which one isomer is converted into another. That means straight chain is converted into branched. And when you check the molecular formula, it is having the same molecular formula, both the reactant and product. Next is the aromatization reaction. Word name says aromatization. That means formation of aromatic compound from aliphatic. So that is actually better, we can write this equation in this way. This reaction is called as aromatization or reforming. What is this reaction says? N-alkane. Again we have taken N-alkane having 6 or more carbon atoms. That is, we have taken here 6 carbon atom. This is also possible for N-alkane having more than 6 carbons also, which is on heating to 773 Kelvin at 10 to 20 atm pressure in the presence of oxides of vanadium like V2O5 here, which is given, and or molybdenum or chromium. So what is actually happening here? It will give rise to cyclic structure, that is actually aromatic structure is formed here, which is getting cyclized. That means the straight chain compound now it becomes cyclic and it actually the aromatic compound is formed here. That is why it is called as aromatization. That means the Straight chain one is converted into cyclic, and that is the aromatic compound is formed. So this reaction is called as aromatization, or we can also call as reforming. So this equation, you can learn this equation in this way. So here the 6 carbon is shown here. Even we can prepare a like toluene. We can prepare toluene. What is the formula for toluene? When the benzene ring having CH3, then it is called as toluene. So here we can take one more carbon extra, that is CH3. This one is CH2. So that is 7 carbon. When we take 7 carbon alkane, N-alkane, we'll be getting toluene as a product. So toluene is the product which is also aromatic hydrocarbon which is formed from N-alkane. So formation of aromatic product is taking place. That's why it is called as aromatization. Next is a reaction with steam. Methane react with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen as the product. So here methane that is reacting with the steam in the presence of nickel, because here nickel is acting as a catalyst and the formation of product is taking place as carbon monoxide and dihydrogen gas is formed here. This method is used for the industrial preparation of dihydrogen gas. We have learned this equation already in the chapter hydrogen. While discussing the preparation of dihydrogen, we have learned this equation, that is the preparation of hydrogen gas from alkanes. So this reaction is the reaction with steam. The next is pyrolysis. That is, the higher alkane on heating to higher temperature, it decomposes into lower alkanes and alkenes, etc. So such a decomposition reaction into smaller fragments by the application of heat is called as pyrolysis or cracking. Now what the meaning word cracking? Cracking means breaking down. So if a bigger chain carbon alkane, if it is broken down into smaller one, then it is called as cracking or the pyrolysis. Lysis means breakdown here, and here it is breaking down in the presence of applying the higher temperature. We are applying the higher temperature to break down the higher alkane into smaller alkane. You can see here this is 6 carbon alkane. Now it is broken down into 4 carbon alkane, and here 2 carbon alkane is formed. And similarly in the next case you can see this is an lower alkane, 3 carbon alkane, and here there is a formation of alkene also, it is formed here. So when it break down by applying higher temperature, it will break down into smaller alkane, and even it can also form smaller alkene. So this is actually called as cracking or pyrolysis, that is heating of higher alkanes with high temperature, it decomposes into, or we can say break it down into lower alkanes and alkenes. This process is called as pyrolysis. So here we have learned a number of equations, that is the chemical reactions of alkanes, and all these equations are important. So learn the method I told you to. Learn the equation instead of by hearting the equation. Learn the method of framing the product. So this is all images are taken from the textbook. So better note it down from the textbook itself. So this is all about this video. Have a nice day.